So good afternoon, everyone. My name is Dwayne Wessels, and I work for VeriSign, and I'm here to present on behalf of the VeriSign root zone team. I'm going to tell you a little bit about VeriSign's role in management of DNSSEC for the root zone, and going to make you sit through a little kind of like a vacation slideshow, show you some pictures that were taken at VeriSign earlier this year when we converted over to the validatable zone. And I have one obligatory graph to share with you. So briefly, VeriSign is responsible for the zone signing keys in the root zone. Typically, a sign zone would have zone signing keys and key signing keys. The KSK responsibility falls to ICANN, and right after my talk, we're going to hear from Mehmet from ICANN, and he'll tell us a little bit more about what they do. The ZSK is a 1024-bit key with SHA-256. This key gets rolled over every 3 months, and VeriSign's cryptographic business operations unit is responsible for generating and maintaining all of the key material. So every 3 months, there is a ZSK ceremony within VeriSign. There are approximately 6 employees who are designated as trusted persons. They are involved in the ceremony. The ceremony takes from 20 to 25 minutes. Previously, these ceremonies were held in VeriSign's facilities on the west coast of the United States, but those were sold to Symantec recently, so we're in the process of building a pair of new facilities on the East Coast that will be used for future ceremonies. So the output of a ZSK ceremony is something that we call a key signing request, and this is the bit that gets sent to ICANN. So my initial feedback from the program committee was that my talk was a little bit light, so I thought I'd throw in this nice chunk of XML to beef it up a little bit. This is a snippet of what the key signing request actually looks like. As you can see, a lot of XML markup, and then there's some time periods and some time stamps and TTLs and so on. It's actually quite a bit longer than this. This is just the bit that would fit on the screen. So ICANN holds the KSK ceremony, of which there have been 2 already, and the main output of that is to sign the ZSKs and the KSKs also. Since the ZSKs rolled every 3 months, these ceremonies are obviously held every 3 months. The output of their ceremony is something called a signed key response, which is confusingly has the same letters as the KSR, just in a different order. So the signed key response contains RR SIGs, and those are then added into the root zone data. So in terms of generating the root zone, twice a day at VeriSign, a new root zone is generated, and this is not new with DNSSEC. It's always been this way. There are numerous checks on the content of the zone. Most of them are automated, but a few of them are manual. One of them that's done manually is that all of the changes, all the non-DNSSEC changes between the current zone and a candidate zone must be correlated to an authorized change. Zone signing occurs within a secure facility. There's a number of signing servers that pull in the zone data to be signed. It gets signed and then it gets pushed back out. So this is due to a security policy that you're not allowed to push anything into the signing system. It has to pull for it. Every time the zone is signed, all the signatures are generated freshly. And after the zone has been signed, they get pushed back. There are a number of validation tools that are run on the signed data. One of them is written in Java. One of them is written by me in Perl, and I'll talk about that in a second. The output of those tools are sent to folks in the ResOps team, the resolutions operations team, who inspect that and then manually approve the zone to be published. At that point, it gets pushed out to the DNS stealth masters and the FTP site. So the tool that I wrote to do the validation of the root zone is available. It's open source and available on that URL there. It's a pretty good tool for small zones like the root zone. You may not want to run it on zones with millions or maybe hundreds of thousands of entries, but it does basically two things. First, it does a crypto validation of the candidate zone just to make sure that the signatures are valid, and it does a
summary of a comparison between the candidate zone and the current zone, telling you how many keys are added or removed or signatures changed and so on.
So next, I just want to share with you some photos that were taken on July 15th, which is the day that the root zone was converted from unvalidatable to validatable. This was, kind of a big deal, as you might expect. And I want to give credit to some of the people at VeriSign who worked really hard on this. This is Pete Barber, who some of you may know. I think he's been to a NANOG or two. He works in the naming resolutions operations team. And one of the things he did for this project was to develop these very long and detailed checklists about all the things that need to happen in transition from a non-DNSSEC zone to the DERS, and then from the DERS to the validatable zone. This is Brian Coppola and Ramesh, with a very long name. Sorry, Ramesh. Brian was sort of the lead engineer for the resolutions operations team, and Ramesh actually wrote some of the other validation tools that are used on a day-to-day basis. This is Brad Verd, who's the director of the ResOps team, and I believe he gets credit for the idea of the DERS, and Mike Rader from the Naming Product Operations Group. Here's Colleen Lowe, who was sort of the project manager for the DNSSEC on root project at VeriSign. Tim Rowe, who is actually Brad's boss, and Greg Patrick, who works also in the ResOps team, keeps an eye on a lot of the servers there. This is Thomas, who was scheduled to be the staff member on duty to review all the and make the manual approvals the day that the root zone was to be signed. And you can see that he's wearing these white gloves here. This is not a normal thing. I think his rationale here is that in case something went horribly wrong, he didn't want to leave any fingerprints behind on his keyboard that could be traced back to him. So he was being very cautious here. Here's Matt, who many of you know, and as you can see, he's holding a printout of the root zone, and I think he's gone through and manually verified every signature with his trusty HP calculator and given his thumbs up that it's good and ready to go. And here's a bunch of people hanging around Thomas's cube as he's getting ready to push the button, and I think people may be on their phones with their brokers deciding whether or not to sell their company stock or to hold on to it, and waiting to see how this is all going to play out here in a few minutes. Yeah, it probably would be. So just because I can't give a talk without throwing in a graph, here's some data from July 15th, actually a 48-hour period where right around the maintenance window, which you can see in gray. And the red line represents the rate of DNS key queries to a root. And as you can see during the maintenance window, there's this huge uptick in queries, which is all of us geeks sort of hitting it saying, hey, is it signed yet? Is it signed yet? Is the key rolled over? Is it ready? Is it ready? Is it ready? And I think the official sort of time is about at 2050 UTC was when the validatable zone was actually published. So finally, just a nod to the DERS, which served us very well during its sort of 6-month lifespan. This is the time when we incrementally rolled out DNSSEC to all the 13 root server letters, and I think it was a really great idea. It did a good job of allowing us to watch things very carefully as it was deployed, and of course we didn't, during this transition we didn't discover any brokenness or any significant problems, so thank you to that, and I'm done. Do we have time for questions?
Yeah, we do. So, does anyone have any questions?
Hi, Patrick from Akamai. Can you go back to the graph? Because the graph is, always the interesting thing. Does the A root really get less than 1 query per second normally?
This is just for queries of type DNS key.
Ah, okay, thank you.
Yeah, this is, so it had this spike, and then after everyone realized that it was signed, it sort of went back to normal levels. We would expect this to go up more slowly over time as more people configure trust anchors. Okay, thank you.
Thank you so much. Next we have Mehmet.
Hi everybody, my name is Mehmet. I work for ICANN, and I will just talk a little bit about what we did in the signing of the root and ICANN's role, our facilities, some information regarding staff and regarding the community that has been involved with the root signing process. So as you see, in the root zone and in the slide and on the shirt that I'm wearing right now, this is the DS record that's in the root zone since July 15. This was created on June 16 in a small town called Pepper, Virginia, in the first KSK ceremony. So, this is actually... All right, I'm gonna pass some pages real fast. This is a longer version of my presentation. This is a joint project, obviously with ICANN, US Department of Commerce, NTIA, and VeriSign. ICANN's role is we manage the KSK, we accept the DS records from TLD operators, and we send the updates to Department, update request to Department of Commerce for authorization for VeriSign to implement them. So the design is pretty much based on various aspects. First of all, transparency is very important because this is a key that everybody will be trusting, and for that we would like to be as transparent, as open as it's possible. So there's no question on that. ICANN is working on getting audited as well, and so we are going to be we are going to get ourselves audited towards some standards, ISO standards. High security, we have built all of our facilities with matching the minimal requirements that were set by NIST in order to achieve a high impact system quality, as well as community involvement. So community involvement, I will be mentioning more, but it's like trusted key representatives, key shareholders, as well as crypto officers. So approaching the protecting of the KSK is little different. We don't really have a lot of logical systems that are protecting this key, and it's on purpose, it's by design. What we have instead is the physical security. We have picked two of the big vendors of colocation, secure colocation providers out there, and one in each different coast of the United States. We built two very secure sites, but the secure sites as well built within the specifications of SCIF facilities, which if you have ever worked with U.S. government projects, you would be familiar with. We have some tier mentality, and tiers are basically just separating the duties and the people that can enter inside and perform some work. These are just some pictures that you can find regarding SCIFs in internet, and this is actually our facility. The wall basically has a mesh inside, so it's just not a wall, not a dry wall that you can just walk through. As well, we are in some areas we are also using concrete walls. Some high-level security iris scanners we also use in the systems, and we use highest grade safes that are available in the United States, which is the top, where the top secret U.S. The government documents are kept. Those are class 5 safes that you see in the picture on the right hand side. More pictures are you can find on DNS.ICANN.org. So we do have enforced dual occupancy, separation of duties, external monitoring, video surveillance, motion sensors, and some other sensors out there. There are some ICANN roles. I will not go into too much details about telling who does which role, but I was the ceremony administrator for the first 2 ceremonies, and I will be the ceremony administrator for the third ceremony as well. Basically, that ceremony administrator is in charge of the ceremony, can delay the ceremony, cancel the ceremony, and can make some exceptions depending on the situation, like power goes on, what we do, sort of thing. This has to be an ICANN staff, obviously. Internal witness is our second ICANN staff role, which is a person that takes notes of everything that's happening, and basically that's what goes into our audit logs. System administrator is a separate duty. Basically, he is responsible of all the audit cameras, all the streaming cameras. As you know, we stream our ceremonies. And then we have the safe security controllers. Those are the people that has no facility access, but they have access to the safes that are in the room. I will quickly mention about this. So this is like a diagram that was generously created by one of our SAs. So as you see in this room, I am a CA, and I with an IW have enough power to enter the tier 5 where you see the safes. However, I cannot open the safe. I need a SSC, a safe security controller, to be with me. As well as there's a cabinet that's actually a full 42U cabinet that you see in left hand side. I have no access to that, so I can't disable the alarms. It has to be SA who can control that, but SA cannot enter by themselves there. I cannot also enter to that level by ourselves. So we separated the duties very well to make it so that multiple duties, multiple personnel needs to be present in order to do anything. And basically, I'll provide, there's a DNSSEC practice statement that you can find in root in our website. If you have any root-dnssec, I believe .org. I kind of got excited now and forget the address, which I shouldn't be. But auditing and transparency, as I said, we will be audited. Everything has been transparent. What we are doing has, we don't really have any secrets. Trusted community representatives, you all know, you can see some of them. If you have any questions to them, I have some names here that if you want to ask them what they think about this, and some of them actually go around to different meetings and made some public announcements regarding their look and feel for the ceremonies. Those roles are, I will basically explain. You probably heard the news in the ABC, CNN, and some other TV channels. There is no way to restart the internet. You all know that better than I do. There are no guardians of internet. There's no such thing. So I thought I would mention and say that. But there are some crypto officers. What crypto officers is that we gave this duty to operate the HSMs, which is where the KSK is being stored. We basically are giving the rights of operating this HSM into some cards, into some smart cards, and those smart cards are located in the facility in some safe deposit boxes that are in those safes. However, only the people who has access to that is the crypto officers. So we have crypto officers for both locations, 7 for each location, and we need minimum of 3 in order to operate. And we have recovery key shareholders, and we need 5 of 7 in case of a catastrophic issue. Let's say HSMs all went bad because of some kind of problem that they are all having, and if we need to recreate the key, we would need the recovery key shareholders. I actually could probably mention the fact that in case of losing both facilities, we could also use them, but it's very unlikely to lose LA and Virginia at the same time. So there are some I don't think I have so much time, so I will be skipping some of my slides real fast. And am I right? Okay. So about the ceremonies, we will have 4 ceremonies a day. We are going to be having 1 ceremony in East Coast and then 1 ceremony on West Coast, and then we are going to continue repeating that. Some milestones since last year. Last year, July, August, the project was finally announced. This is the website that I forgot a few minutes ago. It's root-dns.org. January through May, we work with DERS, as Dwayne have explained. First ceremony has happened in Culpeper, Virginia, and basically this is a picture that we took from the first ceremony. You see Ras there, probably, and I happen to wear the suit, second time in my life, first time being my wedding. Yeah, so. And this was not live webcasted because we were not sure whether we would be able to. But thanks to, actually, I don't know if anyone from Justin TV is around here, but thanks to Justin TV, the second ceremony is live webcasted, and third ceremony is going to be live casted with high definition. There are some other items on July 2010, sign and root, and this is the second ceremony with similar faces that you can see in this meeting as well. Again, they made me wear a suit. And then this is the root DNSSEC team. This includes VeriSign and ICANN employees, and they have put so much effort in this, so it's, I think, good to recognize them. ARPA is signed since March, and right now the keys are being managed by VeriSign, and right now we are working on a model just similar like root, and that's going to come up soon. And E164.ARPA is signed by RIPE, as you know, and the other ARPA children are signed by ICANN since April as well. DS submission, you can go to this website to submit and learn more about the root DNSSEC submissions. And this changes like every hour or something, because a lot of interest happening in DNSSEC. So I think this is not the latest, but this is pretty much as close as to the latest status right now about which TLDs have the CCTL DNSSEC implemented. And you can start your validators. Visit our website www.iana.org/DNSSEC. And next KSK ceremony will happen in Culpeper, Virginia, November 1. We will start at 1 p.m. Eastern time. If anything happens that day, some people cannot make it, etc., we will use the backup date of 2nd, and it will be live webcast as well, streamed. So any questions?
Okay.
All
Thank
right.
you, Mehmet.
You're welcome.
That was good. And next on stage is Bess Hardiger. Are you in the room? Yes. Okay, good. You bring your own PC? Yes. Oh, okay. That's very scary, but we'll figure it out. Sorry? I trust you can figure out what to do.
Yeah.
Yep.
The slides actually start.
Okay. Do you have the slides?
We'll see. If not, I have them too. Yeah, I tested it earlier. Okay, how do you make it go to full screen? Oh, there it is. All right. Hi. My name is Wes Hardiker. I work for Sparta, which got bought out not too long ago by a company called Cobham. And I'm going to be talking about, well, you just heard that the root was signed. You now know that everything's done very securely in very big vaults. And a lot of people were checking it right when the root was signed. And then they probably went, now what? Because what happens next? How are we actually going to use this wonderful spiffy signed root now that we have it? So for those of you who, how many people understand DNSSEC really well? Yeah, you got a few. So the prerequisite for this talk is you have to understand it at least a little bit. So here's your 30-second recap to get you through the prerequisite. The root publishes a couple of keys, which were just talked about. There's a key signing key and a couple of zone signing keys. And those are used to generate cryptographic signatures on all the other data. So the key signing key creates a cryptographic signature for the root, for the zone signing key. The zone signing key creates cryptographic signatures for everything else. Now, when you have children, like the root has a number of children, they need to publish NS records and glue records and things like that that you probably are familiar with. In addition to that, they are now publishing what's called a delegation signer record or a DS record. So there is a DS record, for example, for org, and that's a cryptographic hash of org's key. So org has keys, and com will have keys, and net will have keys, and we'll get to that in a minute. Org does pretty much the same thing, for example. They publish a key signing key for the org, which signs the zone signing key, which signs everything underneath it, and, for example, publishes a DS record for nanog.org, except that it's not there at the moment. We'll get to that in a minute, too. So I'm going to go on to where we are today. You know that the root is signed. The interesting thing is that there was a lot of politics surrounding the root signature, and I won't go into those, but there was actually some people that said the DNSSEC would never be deployed because the root would never get signed. Well, it has been signed, so therefore there's no excuses left, right? The real benefit of having a signed root is that it provides a single trust anchor that everything else can link back up to. So there are a number of TLDs that have also been signed. There's about 28, and that was in September, some of which aren't fully operational yet. Some big ones have been signed, including org.biz, .edu, .us, and then there's a whole bunch more that have announced plans but haven't quite gotten to actually rolling out yet. And that includes .com and .net both have published dates where they will spin up. On September 7th, according to SecSpider, which is an interesting website that tries to collect how many zones out there are actually in production, they currently have 25,000 production signed zones. That's actually a decent number, and that's going to go up over time. Now, that's on the publication side. Who's using it is the real question. Who's actually consuming those signatures and checking them? There actually are some major consuming deployments out there, people that are actually validating the data. And some of the big ones are the top 4 Swedish ISPs have actually been validating for a while, and that accounts for, I'm forgetting the statistic. So what you do with statistics when you forget them is you make them even more fuzzy than they were before. So I know it's about 75%, and my memory says 95%, but a significant number of the Swedish inside the country is actually checking zones. Their users probably don't know it, but the ISPs actually are doing it, the top 4. The U.S. government's using it. Comcast has an opt-in program where you can request to do it. I don't know what their percentage is of users that have actually signed up for it. UC Berkeley was actually one of the first to deploy, and they did it as a test bed. They deployed a validating resolver across their entire campus to make sure it worked so that you guys could be next. So I'm going to show some pretty pictures next. And in these pretty pictures, there's some important things to note. I took a web browser, I captured some traffic, and I drew pretty pictures from the traffic. Each line that you will see is one DNS lookup, okay? And it's the result of loading one web page, and the web page will be at the top of the slide. And all the lines are also color-coded. So orange is a query, basically the client or the validating resolver requesting something. Blue is an insecure response, meaning there's no validatable data to go along with it. It's not that it's incorrect, it's just that there was no way to check it. And then green was secured. So obviously we're hoping for the world to eventually get to green. There's also a few red lines which are truncated, meaning they had to switch to TCP, which is common for querying keys. So the first one is, I'm sure you can all see this really clearly, right? That's our website. That's www.dnssectools.org. That's loading one web page. We don't put a whole lot of extra garbage on our web page. Now, I will say that was a brand new instantiation of bind starting up, and it had to do all the priming. So if we remove the priming queries, it gets a little bit simpler. You'll notice that almost all the responses are green. And in fact, the only blue ones there are actually back to the client, because the client wasn't checking DNSSEC. The validating resolver nearby was. Actually, the other interesting thing, as long as I'm here, the bubbles on the bottom that only have arrows going up, that was in the process where I stopped TCP dump, stopped my web browser, restarted everything. I was still getting answers from the previous slide. And so you still get occasionally stuff coming back, some of them which are green and some of which are blue. So that's a fairly simple web page. You can see that things are grouped. The boxes are organizational zones that are authoritative for a particular zone, like org and test.dnssectools.org, for example. Here's a more interesting website, because that's a small one. We don't have any external JavaScript, external images, and things like that. CNN, on the other hand, is significantly more complex. And even if we remove the priming query, it really doesn't help much. You can go zoom in on that on your PDFs at home, but each one of those black dots is a name server. Each one of those boxes is an authoritative zone, like org, and Facebook is on there because they have a like button somewhere, and they're pulling images from all sorts of other stuff. It's actually fascinating to go look at it. And you'll see that there's even some green, because some of it actually is being validated. But again, from the point of the state of DNSSEC today, most of it's blue, and that's what we kind of want to change. So, okay, now we know that things aren't quite perfect yet. They're getting better. What's next? Well, it really depends on who you are. We tend to classify people into 3 different categories. One, if you're a zone administrator, obviously you should start signing your zone. And if we get to the live part of my talk, I'll even show you how easy it is to do that. You should coordinate with your parent. Here's an example. NANOG.org is signed. If you go do a dig for the DNS key, you'll find it has one. If you go do a dig for the DS record, you'll find that org is not publishing one. So there's a gap there in the communication, and it's actually not possible to validate all the way down to nanog.org from the root because of that missing DS record. If you're ISPs, consider at least turning on validation in your resolvers or setting up a side-by-side validating resolver that just pulls in the same traffic and actually answers it internally and discards the answers to see how well it's going to work. That's a common test platform for going forward. And if you're an end user, start using validating applications for improved security. And I'm going to get a lot more into that in a little bit. So first off, zone administrators. Does anybody go to the LA NANOG in NANOG 44? I gave a lightning talk where I did a live signing of an example zone, and I actually did it live, and I typed the zone out live. That was the harrowing part, was typing the zone. Signing it was easy. I'm going to give a little bit more about that later, but there's a link there that you can follow at home for signing your own zone if you want to try it using our Zone Signer tool. Publishing your DS record upstream, we're getting more and more registrars that are actually accepting input fields for DS records and things like that, so you actually can publish your DS record. Not everything is possible yet, but you could always switch to one of the ones that do. And then finally, remember just that a DS record is really, it's what your parent has to have to get all the way securely down to you. Here's an example named.conf file. You can type that in by hand, copying it into your notebook if you want. Obviously, it's easier to get if you go to the root, the DNSSEC root site that was mentioned earlier. A lot of servers, Bind actually doesn't allow for DS records in the trust key list yet. Pretty much all the rest of them do, and I understand that Bind will eventually get there because DS records are quite a bit shorter to type. But it's not a whole lot of configuration, right? If you put the root zone key in there and you turn on validation, you're pretty much done. There's not a whole lot to do. There are some things that you do have to think about, though. Traffic will increase some as you turn on validation. You're going to have to fetch more keys, fetch all the records, and be able to validate them. And it requires UDP fragmentation or falling back to TCP. That being said, remember there's these major sites that have already done it, so don't be too fearful. The root zone trust anchor, you'll need to track changes to it. The root zone, I don't remember the policy, but if I remember correctly, the KSK is going to roll in 5 years. So they're going to change it every 5 years, if I recall. And that's generally, you should always rotate your keys, right? Well, the security in DNSSEC is really no different there. There are automating tracking mechanisms. In fact, Bind's latest software has automatic tracking mechanisms for Bind, for example. I know Unbound does it. Our tools, we have abilities to track keys in just about everything. And then one thing, in the long distance planning point of view, if you're distributing enterprise-wide configuration, if you're distributing configuration down to your laptops for all of your customers and all of your more likely enterprise users, consider the future of possibly wanting to push out that key into them and pushing security directly down to the desktop. And then finally, when sites are unreachable, don't panic. Don't immediately say that DNSSEC must be the problem and turn it off. Do be a little bit intelligent about it and try to look for and learn how to read DNSSEC log messages. If anybody uses LogWatch, we actually published a patch to LogWatch, so it's actually now in the latest version of LogWatch. It knows how to look for DNSSEC responses and aggregate them already. You already have it if you're running a recent version of LogWatch. So, real quick for the resolver operators, what are the users going to see? If you turn on validating resolvers, what are they going to see? Really, they're not going to see much. In fact, if you go do validation today, you can type these in by hand too and try them on your laptop right now in front of you. You'll find that if you do a dig for badsign-a.test.dnssectools.org, it's long to type, you'll get an answer. You shouldn't. I know you shouldn't because I messed up that signature intentionally. It's a test zone. I went and modified the signature. If you're getting it, it means you're behind a non-validating resolver, which at NANOG you are. And if you turn on validation, they just simply won't get the answer because they shouldn't get it. So here's our webpage. This is the DNSSectools.org webpage. There's a couple of Firefox plugins out there that will do DNSSEC validation. Ours is different because we did it very low in the code to the point where the C library that actually does all the DNS lookups take over. If you go look at most of the rest of them, they're only doing the one in the URL. Well, you remember that huge picture that showed all those lines. There's a lot more than one lookup going on. So you really need to validate each and every one of those. So on our web page, we actually have a little bumper in the middle that is being served from that bad signature zone. And if you look before and after, I'll toggle it back and forth, you can see that image goes away. So if you turn on validation, that picture should go away because it's being served from an insecure site. JavaScript being much worse than images, by the way. So after validation, they simply won't get the answers, the insecure answers. It doesn't really matter what they're looking for. It could be web pages, it could be images, it could be JavaScript, IMAP servers, MX records. The Duke Nukem Forever website, you know it doesn't exist, so they shouldn't get the answer for it. Whatever the client asks for, they're going to get the correct answer or nothing. So there's really nothing to be worried about. But that's just the beginning. Now that the root is signed, where can we go from there? What are all the next interesting things to do? Those are boring. Everybody knows how to use web pages. Coming up soon, though, I'd like to see us go to more in-application validation. There's a whole bunch of really cool bootstrapping that we can do, and we can take away some of the really scary, aspects of delivering email and things like that. Secure cryptographic lookups, I think, is one of the most powerful things that we have to go. SSH fingerprints are already being distributed. How would you like to be able to trust it automatically? We actually have modified OpenSSH to allow you to do that so that you can trust the key that you're getting back without actually having to type yes, because you already know it's validated. Direct to HTTPS links. There's people working on, rather than when you type in http.yourbank.com, you should be able to jump directly to HTTPS without going through the HTTP redirect that is so insecure that everybody knows about. And the one that really scares me, now if you're like me, I get about 4,000 mail messages a day, okay? 75% of it is spam. Would you ever notice if somebody took one of those MX records and spoofed it and snarfed all your mail and it went to somewhere else first? It would be one extra received header in your mail. Would you ever notice? It's probably happened. I bet nobody here, would have any clue that it has happened. That's the one that I think I'm most curious about getting DNSSEC deployed for, is MX records along with DKIM, which is the domain key replacement lookups. Think about secured RBLs. Somebody could easily add and delete entries to the RBL lists in order to get their spam through or not through. DNSSEC can fix that as well. But the most important thing is start doing a little bit of thinking. What types of things could you stick into DNS that might be useful in the future? And then go find somebody that likes to go to the IETF and we'll design something in a committee just for you. And then finally, here's the other interesting thing. A lot of people say, well, but all of my users, they're just fine. They're sitting behind, all of my infrastructure in my enterprise, and it's already secure. We do, there's no way that they can be spoofed. I can put up a validating resolver. That will help, you're right. But do your users ever stay at work? Unfortunately, you can't keep them there. I know some of you have probably tried. They do go home. They do go to coffee shops. They do go to conventions like NANOG, which doesn't have a validating resolver. And they do check email from their phone, which is not even a device you control. So in the long run, in order to get security all the way to the client, we really need to look into a longer term approach, which would be to validate directly in the end application itself. So here's a quick pro and con list of validating in a nearby resolver versus doing it in an application. In a nearby validating resolver, you refuse to give them the answers, but they can still be spoofed locally. Even if NANOG was a validating resolver, all of you are operating wirelessly. Well, you're asking your questions insecurely, so you're going to get insecure answers if one person here is out there, trying to redirect all your DNS lookups. On the other hand, if you do it in application, then you get security all the way there. You can do the magical things that I was talking about earlier, like auto key acceptance and things like that. It also provides for much more useful error codes. Specifically, you can actually tell the person the domain doesn't exist. So here's what I like to refer to as the positive negative. These are two screenshots from our Firefox application before and after we instrumented it with DNSSEC. And I went to a website that does not exist.dnssectools.org. You can't read that, so here's the readable version. Now this is interesting. If you go look at what Firefox coders had to do when you couldn't get a DNS lookup, right? The best you know is you couldn't get the DNS lookup. You don't know why. So if you go look at the error messages that you get all these fuzzy things like, hey, did you make a mistake while you were typing? Are you certain that it exists? Because we can't say that it does or doesn't. Are you able to browse other sites? Is your firewall being a problem? You have no idea what the problem was. On the other hand, if you were not able to get a record with DNSSEC, we can tell you positively it does not exist, which means that we were able to reduce the error code list down to something very, very simple. Did you make a mistake typing? That's always still possible. because the domain you typed does not exist. Now, that is much more user-friendly, and it's an interesting side effect of doing DNSSEC, is we can get much better error codes. And then finally, I have a whole bunch of applications that I can demonstrate for you. I'll do those in a minute. I'm not going to do them right now because I'm going to figure out how much time I have left here in a minute. But we have 7 minutes? Okay. So we have Firefox and OpenSSH and mail apps, wget and NCFTP. Some of these applications we're actually submitting the patches back to, and they've already accepted it, like NCFTP and LFTP. wget said that they did, but it's not currently in the repository. We're looking into that. We have a whole bunch of zone maintenance tools like Zone Signer and Rollerd, and these things that allow you to help maintain your zones. And then we have a lot of debugging tools too that you might look into, and our webpage discusses all of them. And then, of course, we have a validating library for instrumenting in applications. Here's an application. A lot of people say that DNSSEC is too big to fit all the way down into the end application. Well, this is running on my phone. This is a screenshot from my phone doing validation. And it's green, the background is green because it's actually validated that our site is secure, and it's validated the signature chain all the way down from the root down to our zone. If you use a Nokia N900, it's in the testing repository, and it's named Lookup. You can go install it. For application developers, here's some resources from our library. We have a library called LibVal that does validation. It's designed to be easy to use. It has an easy to use API. We also have a more complex one if you really want to get into nitty-gritty lookups. And some things to think about. The interesting thing that we've noticed after doing a fair amount of research is that a lot of applications are poorly written and figured that DNS would never change because they were written based on 80s code books and things like that. And they weren't written on modern thought chains that said maybe you ought to have a default statement in a case statement to check unknown error conditions. And that makes it a little bit tricky for some applications. Finally, here's some resources. These are some links for important web pages that have a lot more information than what I can give you here today. DNSSEC Deployment is a blog that contains lots and lots of posts about the ongoing things of DNSSEC. If you follow it, you'll find every new CCTLD or TLD sign will be published as a news article to it, for example. Our tools are dnssectools.org. We have a whole bunch of stuff all the way from whether you're an ISP or whether you're an end user or whether you're a zone producer. And then IANA has the website for where to get those keys so that you don't have to type in that big long hex string yourself. And then dnssec.net is a smorgasbord of links, basically. So quick conclusions. The root is now signed. The time is right to sign your zones and to turn on validation to protect your users and to make use of secured concept. I want you to think about one thing. Think about the possibility of completely eliminating leap of faith. How many of you type in SSH to some unknown host and you look at that fingerprint and you either don't check it or you just feel really queasy when you type yes? Okay, we can actually get rid of that now. That's our future. That's what we're going to do now that the root actually is signed. So please do turn it on and play with it because it's coming. Any questions? Ooh, 2 questions. No live demo.
Robert Evans, ISC. You mentioned that nanog.org doesn't have its DNS record in the .org zone. I just checked, and there are 849 .org domain names with their DNS records in the .org zone. So if Comcast NBCSucks.org can get their DNS record in, then nanog ought to be able to.
I was not going to name the registrars that are accepting DS records because I wasn't trying to avoid publicizing one versus the other, but I can tell you that some of the more popular ones, including Dine was up here earlier, they were actually one of the earliest out to date that will do DNSSEC for you.
Kevin Oberman, ESNet. Have you submitted the patches to OpenBSD to get OpenSSH DNSSEC enabled?
We did actually submit patches to them at one point. Last I checked, they were trying to decide what validating library they really thought was the best one to use. There's actually more than one out there.
No, I understand if you submit anything to OpenSSH as a patch, you will have a long wait before it actually goes in, but if it's not submitted, nothing's going to happen. So
Yeah.
I'm
so-
happy to hear it's
No, it's a good
there
question, and we did submit it, and in fact, we have Fedora RPMs on our website for a whole bunch of, almost all of our applications. You can download a validating Firefox for Fedora today if you go look at our DNSSEC Tools website.
Yeah. Okay.
Michael Sinatra, UC Berkeley. So one quick thing, nanog.org does have a DLV record in the DLV that is operated by Robert's organization. So they did sign, I think, previous to .org, and I don't know if Larry is actually here right now. He could probably comment on it, but they did sign previous to .org being signed. And the other thing is, it is kind of a big mishmash right now in terms of which registrars in org offer DS records and which ones don't. We'll let you put them in.
The good news is that's improving really, really rapidly. But all right, if there's no more questions, please do feel free to contact me either tonight or later. I'd be happy to give you demonstrations of what SSH looks like when you don't have to type keys. I actually nuked my tilde./SSH folder earlier just to prove that you can really do it. So.
Thank you so much, Wes.
They have a question, but I have a comment. Zone signer, I am actually using for my personal domains, and I think for a starter, I mean, it's probably hard to get something like OpenDNSSEC implemented, but zone signer, I doubt if anyone couldn't be able to do it in this room. So if you have a domain and you want to play with it, I personally am using zone signer to sign my domains, and it's a good work. So congrats with that.
I believe we have the only tool that you can fire in a single shot. That's it. There's no other tool. All the rest of them require 3 or 4 command lines.
Yep.
Except for Dyn.
Yeah.
Okay. Thank you, Mehmet. That was... Okay.